Welcome back, Pre-Algebra. We are in Lesson 114, and we're going to talk about probabilities some more, but this time we're going to talk about independent events. Every time that there is an opportunity for an outcome of something, like, for instance, flipping a coin or tossing a dice or spinning a spinner, there is an independent event, or that is an independent event. For each coin toss, that's an independent event. And when I say independent event, I mean that when I toss this coin this one time, the outcome is always going to be one out of two because I can only get one result out of two possible outcomes, right? Just like when I roll one dice, I can only get one result out of six possible outcomes. That is an independent event. However, sometimes we want to have a string of events occur for whatever reason, and those independent events can be linked together to form a relationship. But we still have to consider them as independent events, regardless of the fact that we want certain things to happen. What we're looking for is the probability that those outcomes will happen in that order. So, for instance, let's talk about a coin. If I were to toss a coin, just a regular fair coin, and I know that there are only two possible outcomes, and I'm only get one of those two possible outcomes, but I want that coin to, I want it to be heads, tails, tails when I throw it three times. So the chances of that happening can be illustrated on a tree diagram. So here's my first toss. So on my first toss, I'm either going to get a heads or I am going to get a tails, right? That's the first toss. My second toss, let's say I get the heads the first time. My second toss, I'm either going to get a heads or I am going to get a tails, right? Same thing here. If I got tails the first time, when I toss it again, I'm either going to get a heads or a tails the second time. So let's say I toss it a third time. On that third time, I am either going to get a heads or I am going to get a tails, right? Let's say I got heads, tails. When I toss it the third time, I'm either going to get a heads or I'm going to get a tails. And again, if I started with heads and then I got a tails and then got a heads, when I toss it the third time, I'm either going to get a heads or I'm going to get a tails. Same thing here. I'm either going to get a heads or I'm going to get a tails. So when I toss it three times, I have this stream of events. There are going to be 1, 2, 3, 4, 5, 6, 7, 8 streams of events that could possibly happen. There are 8 possible outcomes. And the outcome that I want, H, heads, tails, tails, is only one of them. So my probability for getting heads, tails, tails is 1 out of the 8. Now we can do that mathematically. We don't have to draw this tree every time we want to do a stream of independent events and the likelihood that they will happen that way. We can just use math. So we would say the probability of getting heads, tails, tails. We calculate that by looking at the independent events, right? So what I do is I say the probability of getting heads in the first independent event is 1 out of 2, right? Because it's an independent event. When I toss the coin up and I catch it and it says heads, I have a 1 out of 2 shot that when I throw that coin up in the air, it's going to be heads when I catch it. Now, it doesn't matter whether it was heads or tails or not when I threw it the first time. When I throw it the second time, I still have a 1 out of 2 chance that is going to be tails, the one that I want. And the same thing for the third throw. It doesn't matter what happened here in the first 2 throws. For the third throw, it's still an independent event. It's not, what I mean by independent event is it doesn't matter what happened here. It will be what it will be regardless of what the first two throws were. So it's another independent event. And I still have a 1 out of 2 chance for it to land on tails on that single toss. So the way we calculate probability is by looking at the independent events and saying, what is the probability of that one independent event happening the way that I want it to? And then we multiply that by each independent event's probability. And that ends up being 1 out of 2 times 2 times 2 is 8. And that was a lot easier and took a lot less paper than drawing out a probability tree or a tree diagram. So what you do is you just do the probability for each event and you multiply them against each other. And that is the probability that I will toss heads, tails, tails in 3 tosses in a row. And you can see that illustrated here, heads, tails, tails. This is the probability that it will happen the way that I want it to, is the 1 out of 8. Okay, so let's move on to the first problem and see if we can calculate that one, okay? All right, our first problem says, a fair coin is tossed 3 times. What is the probability that it will come up heads every time? So you have to ask yourself, if it's tossed 3 times, right? That was what we just got through talking about. We want it to be heads every time. Does that change based on what we want? Because the last time we wanted heads, tails, tails. Is our probability going to change because what we've desired changes? Well, let's find out. So the probability that it will come up heads the first time is 1 out of 2, because it could be heads or tails, but we just want heads. So that's 1 out of 2. That's what we want. We want a 1 out of 2 probability, or a 1 out of the 2 possible outcomes is what we want. Now that was for heads, and you could put a little mark so you don't get lost where you are. You know what you've already done. I like to label them. Labeling them is perfectly fine if that helps you keep track of where you are. So the second time we want heads, and then the third time we want heads, right? So the probability of getting heads on another roll or just another independent event is still the same. It's 1 out of 2. I have a 1 out of 2 shot of getting heads when I toss the coin again. Doesn't matter what happened before. This is an independent event. Okay? So now the probability of getting heads again when I toss it up is still 1 out of 2, because there's still only 2 outcomes and I want one of them. So that's the stream that we want. Let's see what the probability of getting that is. 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. So it doesn't matter that what I want has changed. I still only have a 1 out of 8 probability of getting the stream I want in 3 tosses. Interesting, isn't it? All right, so let's look at the next problem and see what that one says. So this is another fair coin problem. Let me write that up here for us. All right, so this problem says a fair coin is tossed 4 times. What is the probability that it will come up heads on the next toss if it has landed on tails 4 times? So we want it to come up heads on the next toss. That is, there's 2 possible outcomes, heads or tails. We want it to land on heads. That's one of the possible outcomes. So the probability that it will land on heads on the next toss is 1 out of 2. That's it. It's that simple. It does not matter that what it has landed on the previous 4 times. There is no link or relationship in the toss. As long as it is a fair coin, meaning it's not weighted in any kind of way, whatever it lands on is whatever it lands on independent of what it has landed on before. So just because a coin has landed on tails the 4 times previous, there's no more opportunity for it to land on tails or heads in the next toss. Your shot is still 50-50. You have a 1 out of 2 chance of it landing on what you want it to land on in the next toss. And that's why people use tossing a coin so many times as a decision maker if it's, a hard decision to make, because they know it's going to be whatever it is. It just is whatever it is. It's an even shot. And that's all we have for lesson 114. I will see you in lesson 115.